All right, so to prove that this is divisible by 5, a function of this nature, by 3, we are going to start by saying let f of n be equal to n cubed minus 7n plus 9. All right, so stage number 1 is to prove that f of 1 is equal to 1 to the power of 3 minus 7 times 1 plus 9, which I believe is 1 minus 7, which is minus 6. Is it? Plus 3, is it 3? So the answer is 3. Is that okay? So we must also remember that n here has to be always an element of the positive integers. So we can see that f of n is divisible by 3 when n is 1. So you can actually make a conclusion here, which is divisible by 3. Right? Next step is to go to the assumption stage. So we assume that for n is equal to k, f of k, which is equal to k cubed minus 7k plus 9, is divisible by 3. So this is our trump card. This is our trump card, number 2, statement number 2. Then we move on to statement number 3. We want to prove, we want to show that when n is equal to k plus 1, f of k plus 1 is also divisible by 3. So this is what we want to show. So let's write f of k plus 1. F of k plus 1 here is actually going to be equal to k plus 1 to the power of 3 minus 7 k plus 1 plus 9. That's what it's going to look like. All right. A quick expansion of k plus 1, because this is just a Python, what do you call it? The Pascal triangle is 1331, isn't it? 1331 is going to be equal to k cubed plus 3k squared plus 3k plus 1. Then I'll expand what's in here. I'm going to have minus 7k minus 7 plus 9. And this turns out to be k cubed plus 3k squared minus 4k plus 3. That's our answer. We have no way to say this is divisible by 3. We can't tell, because the individual elements in f of k plus 1, the only element that is divisible, there are 2 by 3 here, by just looking at them, is 3k squared and 3, the last term. So we can't tell. All right? So, but what we can do here is to say, let us have f of k minus f of k. F of k plus 1 minus f of k. And when we do that, we are simply saying k cubed plus 3k squared minus 4k plus 3 minus, in brackets, where is our f of k? The one in red, which we know is divisible by 3. And what we get here is something that we are going to like, is 3k squared. Yeah, because you can see the cubes are cancelling each other, plus 3k minus 6. Beautiful. A quick look at this, we can actually factorize 3 and we get this. Oh, sorry, we get k minus 2. So the difference of these two functions is actually divisible by what? By 3. Do you see that? Now, remember that from our statement, f of k plus 1 minus f of k gives us 3k squared plus k minus 2, which further implies that f of k plus 1 is equal to f of k plus 3 k squared plus k minus 2. Do you see that? So f of k plus 1 can be redefined as f of k plus that difference. But look at f of k in number 2. We already declared that f of k is divisible by 3. And 3k squared plus k minus 2 is also divisible by 3. What does that tell us? The principle of linearity tells us that f of k plus 1 is also divisible by 3. By what? By linearity theorem. And hence by the principle of mathematical induction. This whole scenario is divisible by 3. Make sense? Perfect. We are done with divisibility.